Here in this question, a charge is kept at central point P of a cylindrical region. This is the position where the charge is being placed. The two edges subtends half angle of theta at P as shown in figure. This is the half angle here. When theta is 30 degree, then electric flux through the curved surface of the cylinder is phi. Well, we can write down here as phi will be the flux. That means if the total surface area subtends an angle of 4 phi, then flux happens to be how much? Q by epsilon naught. So that means we need to find the flux through this much of the region and this much of the region. So flux through this much of the region will be written as phi, that will be equal to Q divided by epsilon naught minus Q divided by epsilon naught 4 pi into 2 pi here, 1 minus cos of 30 degree, that is for one side here, other side is also included, so I'll multiply here with 2. So what I'm getting here, it will be equal to Q divided by epsilon naught. This 4 pi will cancel out. I will have 1 minus 1 minus of cos 30, it is coming out to be cos 30 degree itself. So this is the flux in this particular case. Now in another case, if the angle is 60 degree, then the electric flux through the curved surface comes out to be phi divided by square root of n. So I will write it down as flux now will be equal to phi dash. So it will be equal to Q divided by epsilon naught cos of 60 degree. Divide these two parts together, I'll be getting phi divided by phi dash will be equal to root 3 by 2 and here 1 by 2. So that is coming out to be phi dash equal to phi divided by root 3. So matching with the format given here, I can clearly see that n is having the value of 3. So I'm getting 3 is the answer for this question. We can verify here in the sheet provided. Well, 3 is the answer for this particular question.